Hello, everybody. I think I'm live. Hi, everybody. Thanks for joining me today. My name is Stephen Bailey. I'm the Director of Growth Analytics at Immuta, and it's my pleasure to talk to you today about data governance in the modern data stack era. This is a talk that I really enjoyed putting together. It's the outcome of a lot of work and a lot of research and a lot of experience over the past couple of years setting up the modern data stack at Immuta, which is a data governance company. So I want to not bury the lead here and instead present a thesis to you right up front. And this is what I call the ELT-G thesis. It goes like this. The modern data stack has been so popular because it enables really rapid development of data products, and it really assumes a high level of interoperability between systems. And so it allows data teams to be very efficient. If we think about modern data governance and what it could be defined as, I think it really has its fundamental reason in metadata management. It's all about purposefully administering metadata in a way that enables data teams and companies to leverage their data more effectively. But across the industry, across all of our data teams, the specific governance processes are super variable. Some people are very mature, some people have no real governance processes or no real metadata management framework in place. That it's hard for us to have a conversation about governance really today. But I think that we can come to an agreement. I think we are coming to an agreement about where governance happens and where this metadata management takes place in the data ops and data lifecycle. And that is that it happens at the point of release. So you have data processing on the left-hand side, so the data supply side. You have data consumption in all of its different forms on the right-hand side. Governance is most effective when it is able to influence the release of data and the meaningful communication about the data assets available, being provided by the data providers and being consumed by the data consumers. So ELT-G governance happens after the data processing lifecycle. This talk is divided into 3 parts. Move forward slides. This talk is divided into 3 parts. The first is ELT and data decentralization. So I want to talk thematically. What are some of the changes that we have going on right now in the industry? Then I'm going to talk about specifically governance and data processing, and specifically around access control. What are some innovations that are happening and possible by abstracting governance from the ELT process and putting it right between the supply and consumption side. And finally, I want to just end on thinking about how this impacts us as humans, because ultimately I think governance is this fundamentally maybe the most human process in the whole data lifecycle. But first, I want to talk about trains. I think trains are an incredible technology. They created an industrial revolution and really enabled people to innovate in ways that they were never able to before. If we think about the technology of the train, I think there's some interesting features that are relevant to us as in the data industry. Trains were piloted by an experienced professional driver. It wasn't like anyone could just hop in a train and drive it. The train itself had a locomotive on the front, and then you could couple a bunch of cars to it. And so it was a very efficient way of transporting large volumes of data, volumes of commodities across long distances. Very efficient, very powerful. And the infrastructure that the train rode on was tightly coupled to the design of the train itself. You couldn't have like different gauge tracks and a train that had incompatible wheels on it. It just wouldn't work. And so you had a tight coupling of the infrastructure and the technology. If you fast forward 150 years and think about the modern road system, you have this total decoupling of the infrastructure that cars drive on and the vehicle that drives on it. And this decoupling facilitates a great amount of variety in the types of cars that can be driven. You could have a car, a bus, a bicycle, a motorcycle, a semi-truck, a tank. Doesn't really matter because you've decoupled what the infrastructure is that the vehicle drives on. It just has to have wheels. That's had some societal implications as well. You have vehicles can be piloted by virtually anybody. Anybody can ride a bike. You get licensed to drive a car. So there's a lot of variety and heterogeneity. It's also super efficient for the individual to get somewhere. Way more efficient than waiting for a train that only goes at certain times and comes at certain times, even if they're maybe way more reliable and less risky in some ways. The technology changes from train to automobile have created changes in the way we organize ourselves as people and the way we educate ourselves and the way we build our cities. If you think about all of the things that go into creating a safe roadway environment, it's pretty incredible. And we just take it for granted. There's all sorts of signage, stoplights, there's walkways and crosswalks and conventions around when you can move. Services, patrol cars, emergency services. We have training and licensure, a whole industry around insuring vehicles, not to mention a whole economy around selling vehicles. The technology changed, and so our behavior changed, and so the way we organized ourselves had to change as well. Hopefully you can see where I'm going with this. Traditional data warehouses that we built in the 80s and 90s were kind of like trains. They're powerful, they're efficient, they're bound to a specific infrastructure. They required a huge capital upfront investment to create. There was a 12-month planning cycle initiated by the central IT team to figure out what data sources are going to come in, how we're going to merge them, are we going to stage them in one area, then create a warehouse with a bunch of different marts. Everybody in the business was involved. It was a capital B, capital T, big thing. It was like an initiative. Modern cloud data warehouses and SaaS applications are like cars. They're decoupled from the business process, the IT team. They're modular. They don't require a big capital upfront investment, and anybody can drive them. Really, you can do. When I was building our internal data analytics team, it was like I could get all of my pieces of my puzzle up in a morning, even as someone who had never done the data warehousing thing before. And it was pretty good. It wasn't like it was a shabby knockoff. It was like production quality. We're still using the same stack today. So it's not, you get a lot of the benefits, but it does come at a bit of a cost. This is a great diagram from an Andreessen Horowitz article on the modern data ecosystem. I don't want to look at any details really, but I want you to see on the top here we have different categories of technologies: sources, ingestion, transform, storage, historical, predictive analytics, output technologies, consumption, dashboarding tools, and then you have some other stuff down here. But the feeling I want you to get is that looking at this diagram, if you're a new data person or if you're not a data person, this is bananas. It is like New York City at rush hour, just overwhelming. And coupled to that, from a data governance perspective, if you are a person and you want to get a handle on where your data is in an organization, it's so hard. It's so easy to transport, transform, connect to new tools that a data consumer can quickly become a data provider for another system, and it can just proliferate very quickly. I think, I've read in several places that, the days of having a purely centralized warehouse are just kind of gone, right? Like it's too easy and it's too useful to be able to spin up a new data storage thing that we're just not going to be able to stop people from doing it as we move forward. And so our behaviors need to change if we are going to govern our data, and we have to govern our data. If we're not doing it well, then we face economic risks as a company. There's culture risks if if data starts leaking out that shouldn't be leaked out, whether it's your employee data or customer data. That creates a bad environment, and we can't forget that a lot of the data that we have relates to people, and from a privacy, like a respect of people's privacy perspective, but also just the fact that you can do real harm if you're not being a good steward of your data. We just, as a community, have to develop practices that we can rely on and use to protect our data. So the governance challenge is acute and it's important. So I want to take that sort of theme and boil it down into some specific domains where data governance is evolving, and then talk specifically about things that we at Immuta are doing to implement this modern data governance approach that focuses heavily on metadata in the realm of access control. So I showed you that diagram about the different technologies. I want you to focus now on the bottom set of technologies that don't have a category. They literally they aren't like categorized in this diagram. And I think it kind of is telling about how we think about data governance currently. They put 4 groups of functions in this group. Metadata management, kind of like catalogs. Data quality and testing. There's some folks here today who are talking about data quality and testing. Entitlements and security, access control, and observability. So seeing what's happening in your pipelines as it's happening, being proactive about addressing issues, things of those sort. Well, I think these 4 things, which are highly technical, it's not like these are just business, this isn't just like some business requirement that's being implemented. These are very technical, sophisticated subdomains that are very interesting and hot right now. I think that's modern data governance in a nutshell. If you think about the things that are priorities in these domains, in metadata management, establishing standards across the organization, principles and procedures that people need to follow that apply to data that's onboarded, SLAs, data quality. How do you take all your existing data assets and understand if they're performing as expected or not, and be proactive about treating issues. Observability, kind of the same thing. And then entitlements and security. How do you actually implement privacy measures in a meaningful way? It's all about metadata management and being able to enforce these things in production pipelines. So where does this happen? I think that's one of the issues we have, right? In that diagram, everything had arrows moving to and from, except for the stuff at the bottom. Does it just happen? No, it has to happen somewhere and influence some process if it's going to actually do anything. Is it on the supply side? As you're processing the data and then you just kind of release it? Is it at the demand side, or is it maybe at the intersection of these 2 things? And that's exactly where I would argue that governance happens. It's where the supply meets the demand. It's at the release of the data from its processing environment into the wild. That's where you want to know about data quality. That's when you want to know that, hey, the pipelines are working. That's where you want to know, where end users want to go and see metadata about what is this data, are other people using it. That's where you have to enforce privacy controls. In the Immuta world, in an ELT-G framework, that looks kind of like this. I've got 3 layers in this diagram. On the left side, we have a metadata layer that sits above the data layer. We have a typical extract and load transform pipeline that's operating in a database, maybe Snowflake or Databricks, Presto. Immuta sits at this intersection of data processing that's happening and then data consumption that's happening. It unites metadata from the identity provider, from your pipelines, from your catalog of data, and it creates secure views that people can access and use in their tools of choice, like Looker and Tableau. I think Immuta is really interesting really situated in a very interesting place, because I would say that access control is the original metadata problem. I might argue that it's so original that we don't even think of it as a metadata management problem in a lot of the data ops conversations that are happening right now. There seems to be an assumption that, hey, it's roles, you got roles and that's it. But I've had firsthand look into some of the features and our approach to attribute-based access control, or even policy-based access control. And I think it's really innovative. I think it's really interesting. I think it really deserves a lot more recognition for the complexity of the problem than it often gets. So I want to drill into 4 topics that talk about how putting governance right after the data processing side and right before the data consumption side, creating a sort of a governance pillar in that spot can really allow teams to innovate on how they're doing access control in particular. And these come from the way we've, these are all around the way we built the product, which we're using internally, by the way. I lead that initiative, and it's been very very exciting to me. So the first thing I want to talk about is separating utility or value transformations from governance transformations. We use a tool called DBT. It's a fantastic tool. I really love it for its simplicity, for its opinions. It gives me, as a data platform owner, a really nice way to organize a workflow around creating new data assets in our data warehouse. But it's really good for refining data so that it fits a certain data model for our warehouse, or answers a certain business question in a way that's very well managed. These are things like standardization, aggregation, data cleaning. It's really great for that. But there's this whole set of transformations that are they're kind of hard to bake into a data model. These are things like access control, row level security, actual like anonymization, masking lots of columns in a database, and particularly dynamic masking of lots of columns. These can be pretty challenging to implement, to hard code into your transformations. And I think they're distinctive because they often require contextual information about how the data is being released, who's using the data, what attributes does this person have. And so I separate them out. I think these are called governance transformations. And I want to show you an example of what I mean. If you're on a small team, you might have a data processing pipeline that looks like this. You land bronze data or raw data in your data warehouse. You use some sort of transformation process with some transformation tool, maybe just SQL statements, and you create gold data that you want people to use. Well, then you release it to everyone in your organization when you're small, because everyone kind of already knows everything. So what's the point of hiding it? At some point, you start saying, okay, well, this data probably shouldn't be seen by everybody. So one way you might approach this, if it's PII, for example, is you might make a masked version and an unmasked version. And some people get access to the unmasked version and some people get access to the masked version. That's great. Still small, that works. But then you might start having additional requirements. Maybe there's another dimension that you need to filter on, like privileged data versus unprivileged data. So you got PII masked, and then you got to mask finance data from the rest of the company. Well, now you're starting to make multiple copies of the data and multiple roles to access that data. And it starts to become impure and a little complex. And it's kind of frustrating because the simplicity and beauty of having a dedicated data transformation layer starts becoming corrupted by all of these kind of contextual dependent governance transformations. Well, if you could abstract that logic and drive it off of metadata, and then just implement views that are dynamic based on the context of how it's queried, well, then you can recover that purity of your gold data, abstract your logic into something that is separate, and then unite it when it needs to be united. And that's essentially what Immuta does by creating secure views that are based on some user attribute tables. It makes for a very nice experience. The second wrinkle to that technology is that it abstracts the policy from the underlying technology. So let's go back to this setup where you have gold data with PII and masked PII. You've got two groups, not too bad to handle. Well, let's say your vendor increases your bill or your rate, or usage spikes and you want to go to something that's provisioned once. It's not compute cost. Well, you might want to switch to another technology, or maybe two more technologies. Well, now you've got three different database systems that are all implementing their own specific types of logic, or at least implementations of the same logic, and you have to manage them separately in three different places. Well, if your policy logic lives in a metadata layer above the data layer, then you can just translate that policy logic into the appropriate action for each of those systems. So you've separated, you've abstracted the release logic for your data into another layer. And this starts becoming super useful when you have slightly different versions or slightly different teams doing slightly different things that all invoke the same policy, like mask PII. Anyone can understand, regardless of the technology, what that policy is, overarching policy is, and then and everyone needs to implement it despite using different technologies. Two more. The third way, abstracting the governance logic helps, is it helps establish a comprehensible language around data. One of the things that we see teams often have to adopt very quickly when they start using Immuta is they have to define their policies, and they have to think more critically about what the language around their policies is than they've ever had to before. Because instead of looking at an individual data source and making an individual decision based on an individual data source and content of that individual data source, you have to think of a policy and a policy language that can apply to multiple data sources. So you start thinking about, okay, how are we going to define these tags? What granularity do we have to think about for a certain tag? What are the different dimensions that we have to implement access controls on? What this does is it starts taking the policy, the explainability of the policy, to a much better place than you have with just roles, for example. This is a diagram from NIST about different access control models. What I want you to see is on the x-axis is the granularity of access control, so from rough-grained to fine-grained access control. And then on the y-axis, you have the explainability of the policy. So the key difference between a role-based access control and attribute-based access control is that you get a lot more finer-grained in the way that you can write a policy. But then there's a level above that called policy-based access control, where you start getting more explainable. You don't necessarily add any granularity to what you can do, but someone new to your organization can come in and they can say, oh, you guys mask PII for all people except people in marketing, or you mask PII except when people are doing a specific project that's been authorized. Wow, I understand what's happening here. If you go in and you show someone your set of AWS IAM policies, they will not say, oh, I understand what's happening here. This is an example of an Immuta policy that implements the California Consumer Privacy Act, Consumer Privacy Act, in a way that's machine enforceable. And if you read just a row or two, you can see that it's explainable. You're limiting usage to a certain purpose for everyone except when they're acting under this authorized purpose. You're masking columns tagged direct and indirect identifiers by making them null. Having that comprehensible language is very important to implementing scalable data governance. And finally, I want to talk about the additional levels of privacy controls you can implement when you're abstracting the governance out. One of the things I think is amazing is the privacy by design framework. Something I wish a lot more people in data talked about. It's this approach to protecting your data assets, especially those coming from consumers, that requires forethought and principled design decisions around process monitoring, security controls, access controls, and also limiting data collection and just doing an evaluation of how you're protecting data. There's some examples of good ways people have done this. Academic institutions have institutional review boards. Teams in Europe are probably familiar with data privacy impact assessments. Google's come out with like model sheets, model cards, and data sheets. But without having some sort of system that can make decisions that influence your data processes, these things to me feel like exercises. It's very hard. Like if it fails, if your privacy impact assessment fails, does it restrict access or does everything just kind of continue going along? Being able to make decisions based on and influence data release is a super important consideration we have to make when designing these privacy controls. So my take-home point here is that modern data governance lives between the processing and consumption. Access control is one great example of an area that can become very innovative by abstracting governance into a metadata layer and then injecting decisions based on that metadata back into the data pipeline. But it rings true, of course, for those other areas: data quality, observability, and metadata management. Just want to end on a quick word about the fact that governance is about humans. It's about our organizations, it's about the way we treat data in our organizations and the way we communicate about data. There's a great book called Data Management at Scale, presents a nice framework for thinking about the future of data governance, but he has this great quote in it that talks about the future data governance work. It's going to heavily involve metadata integration and defining principles, policies, rules, and standards that fit the enterprise's goals and risk appetite. There's not going to be a one-size-fits-all approach to data governance, but we should be able to get to this place where we can share, like data teams can share best practices around governance and who should have access and how should you protect data. We need to have these principles and be able to make decisions about these principles that are implementable and communicable. We have that with a lot of our data processes, but I don't think we're there yet with a lot of the metadata processes. I'll put this in I shared this in the I think in the studio thing, the PDF of this. I don't want to go here into depth, but if you take any of these governance domains, I think you can assess your team and think about, are we crawling here or are we walking? How do we get to run? The whole governance spectrum is a journey, and I think as we focus on it and we inject it into the ELT-G into the data process, love to see us share a lot more experiences of how we went from crawling and access control to running and really doing innovative work. Finally, I think we can develop excellent practices as a community, but we have to dedicate the time and energy to scalable governance and then innovate within that space. We have to make space for data governance in the data pipeline, because if we as data engineers and data platform owners don't, then I don't think there's anyone who's positioned to do it well. I think data governance will continue to kind of spin by itself as this thing that everyone knows they need, but they don't know how to implement it. So that's my call to action: is as we innovate and as we build our platforms, let's really focus on governance and thinking about how we release data responsibly to our data consumers. All right, thank you. I guess it's 2:30. I'm happy to answer questions as long as I'm broadcast, if anyone has any. All right. Well, thank you for joining, and I hope you have a great rest of the conference.